In this video, we are going to look at more problem solving. Specifically, we want to look at an application involving a moped. You are really excited to have found a Puch Maxi moped from the mid-80s, and the spring weather is making you want to get out and ride. Your Puch Maxi moped does not run on straight gasoline. Instead, you have to mix the oil and gas together in a specific ratio of 2.4 fluid ounces of oil for every gallon of gasoline. You have 2 quarts of gas to fill the tank. How much oil should you add? There are many different ways to approach this problem, and the way that you do it and I do it might be very different. But I'm going to use some of the tools that we've been talking about, specifically either dimensional analysis or proportions. I think this problem speaks proportions to me, so that's the route I'm going to go. But again, the way you choose to solve this might be very different. As long as we get the same answer at the end, that's what counts. So here we go. Let's get started. The reason I'm thinking proportion is because when we mix oil and gasoline together, that ratio stays constant. But just depending on the different amounts of gas will change the different amounts of oil that we need. This is the idea of a proportional relationship. In fact, I think my brain says do the following. Let's set up the proportion that 2.4 fluid ounces of oil are mixed with 1 gallon of gas. And the top then represents the amount of oil compared to the bottom, which represents the amount of gas. And that relationship has to stay constant so that when we have 2 quarts of gas, I will then be able to calculate the number of fluid ounces of oil, or how much oil I need to add. So this is what I'm thinking I need to do. 2.4 fluid ounces is to 1 gallon, as X fluid ounces is to 2 quarts. There's just one issue with this setup. Namely, when we have a proportion, our units have to match. In the numerator, I see I have fluid ounces on the left and the right. But in the denominator, we have gallons on the left and quarts on the right, and that presents a problem. I either need to have gallons on both of the denominators or quarts for both of the denominators. Well, how can I go about changing? I think I can use this little note that's given to me, namely there are 4 quarts in a gallon. That's going to allow me to convert from quarts to gallons or gallons to quarts. I think I'm going to choose to rewrite my 1 gallon and rewrite it in terms of quarts. That is, 1 gallon is 4 quarts. So the actual relationship or proportion that I can best solve would be this. 2.4 fluid ounces is to 4 quarts, as X fluid ounces is to 2 quarts. I now have a proportion where all my units match, and I'm ready to solve. So let's focus in then on that proportion. 2.4 fluid ounces is to 4 quarts, as X fluid ounces is to 2 quarts. Because my units are matching, I can ignore the units and simply focus on 2.4 is to 4, as X is to 2. How do we solve this proportion? Well, we cross multiply and divide. So I'm going to take 2.4 times 2, and that gives me 4.8. And then I'm going to multiply 4 times X, and that gives me 4X. The last step I have to do is divide both sides of my equation by the number in front of X. And so that tells me that X is 1.2. What was X representing? X was representing the number of fluid ounces of oil I would need that corresponds to 2 quarts of gas. So I think we've just answered our problem. We need 1.2 fluid ounces of oil added to our 2 quarts of gas in order to go for our moped ride.